Okay, in this problem, the A is the initial point with gravitational potential energy, and then B is the final point with gravitational potential energy as well. A would be PeV, B we'll use as PeF. The location chosen for Y is equal to 0 is also 0 point for the potential energy because P of E equals mg times Y. Alright, for A, I'm going to let Y equal 0 at B and calculate the potential energy at A and at B and calculate the change in potential energy. Okay, so we're going to find the P of V, the potential energy at A, from this equation. We're going to do PE initial equals mg Y initial. So if we plug in our numbers from the givens, we have that equals 60.0 kilograms times gravity, 9.8 meters per second squared, times our 10 meters, which then equals 5.88 times 10 to the third. Alright, so the PE final is going to be as 0 at B by choice. So to find the difference in potential energy between A and B, we're going to use PE final minus PE initial equals 0 minus our 5.88 times 10 to the third. And when we do that, we end up getting a negative 5.88 times 10 to the third. And that's our answer for part A. For part B, we're going to repeat the problem. And if Y is equal to 0 at A, so the P of E is going to be, potential energy is going to be 0 at A. Find the PE potential energy final. We might as well note that point B is now Y equals negative 10 meters. PE final equals mass times gravity YF, which if we substitute our numbers, we get 60 kilograms times 9.8 meters per second squared times our negative 10 meters. We end up getting a negative 5.8 times 10 to the third joules. Oh, by the way, I forgot to put my joules mark on part A. Then to wrap this up, we got the PE final minus PE initial equals 0.588 times 10 to the third joules minus 0, which then makes it equal to minus 5.88 times 10 to the third joules. That is our answer for part B. Now for part C, we're doing the same thing, but if Y equals 2 meters above B. So to find the PeV, the potential energy at A, we're going to have to use PE initial equals mgy initial. Plug in our numbers. We got 60 kilograms times 9.8 times our 8 meters equals our 4.70 times 10 to the third joules. We got potential energy final equals mgyf, which equals 2, so again plugging in our numbers, 9.8 and negative 2 meters. We end up getting a negative 1.18 times 10 to the third joules. And we've got potential energy final minus potential energy of initial. which equals 2 at the end, negative 5.88 times 10 to the third joules. And that is our final answer for part C.